Okay. Hi, everyone. Let's go. So I'm really happy to be here. Bonjour, Lyon. I'm French, so the first time I'm in France presenting. That's really great. So my name is Eric. I work for Zalando, and I work in Berlin. At Zalando, we have a very large engineering organization, and in my department, we are starting lots of very interesting projects. So if you're interested in working in Berlin with me, doing some cool Scala, please come talk to me after this presentation. So how many of you are writing tests every day? Wow, you're not writing tests over there. So, and how many of you like it? A bit less hands, right? So actually, writing tests can be fun, and I hope I can give you some new ideas and new tools today to write some tests. So probably if you're writing tests, you're using a library that does at least this, where you can specify the intention of your test or your specification, what your system is supposed to do with a name, and then you can run it and get some useful report out of this. In that case, it's all green, it's fine, we can all go home, life is good. But this is more or less the state of the art that we had like 15 years ago with JUnit. And now we can do a lot more with testing libraries, especially with a nice expressive language like Scala. So today, I want to make a tour of a testing library called Specs2, where you can do lots and lots of different things. And I'm also going to give you an idea of how the library is implemented, because I think it's actually interesting to understand how the features that you can use as everyday users map onto the actual implementation, which I think is quite interesting. So we're going to talk about all of this. So the first thing we can do with a library like Specs2 is that we can just express ourselves. I mean, in the example before, every method name was actually a textual description of something I wanted to say with using just an informal language. And in Specs2, we can just use Scala interpolated strings to say at length what the system is supposed to do, why it's behaving this way, what's the overall context, and so on and so forth. You can really write real specifications as if they were like Word documents. And inside the text, then you can put some code that's going to more precisely describe what's going on with some real executable code. So this is why in Specs2 is referred as a executable specification library. So you can write specifications, but that are really executable. One interesting thing that you can do with Specs2 is actually sometimes the code itself is so expressive that you don't need a description for it. So if you are explaining what an API does, sometimes the code itself is the only thing you want to see in your report. Because if you had to explain using words what the code is doing, you would more or less say the exact same thing, but only worse. So in Specs2, you can have tests like that, and when you run the specification, you would get the exact same text extracted from the code and displayed on the screen. So this is, I think, a nice feature, and this is called auto examples in Specs2. Another cool thing that we can do in Scala, and I think I dreamt of that feature for a long time. So when I started my professional programming career, for the first 6 months, I didn't code anything. Nothing. My first job was just to rewrite the full specification of the system I was about to work on. And that system was really crazy, because the heart of it was a method in C++ that was 2,000 lines long. I kid you not. So I had to refactor that thing into manageable pieces, because people could not handle this anymore. So the first step was to write specifications. And then I discovered while writing those rules down that having tables, it was a very nice way to display all the different situations, all the different corner cases, and so on. So I always thought, oh, that would be cool if I could have tables inside my software. Because as a format, as a way to display information, it's very useful. I mean, we do that with Excel all the time. And it turns out that in Scala, it's actually possible. So you can, in Scala, have some tables inside your specifications where each row is a different case. And this is purely some valid syntax, and this has to compile, and everything on each line has to align with the proper types, and so on. And when you run this sort of thing, if there's one line that's maybe wrong, has a failure, you will see what's going on, because there's a cross telling you, oh, everything works except on that line. This one, you need to fix something. So it's quite cool to be able to have real tables, but just using Scala syntax. Another thing that you can do to make your Specs2 specification really precise is to use property-based testing, and ScalaCheck in particular. So how many of you have touched or heard about ScalaCheck before? Okay, and you're using it. Yes, so the ScalaCheck is a really, really cool piece of software, and we're using it all the time. And it's really well integrated with Specs2. I'm going to show you one example here. So let's say the previous thing about tables and the way they are displayed, as you have seen, all the columns are nicely aligned. So somehow you need a function that's going to do this alignment. Take a list of strings for each row, and that's going to produce a nice table where everything is properly aligned. So if you had to test this, you could just test it on one example. But you could also describe a property for it using ScalaCheck. So let's see what this property could look like this. So you say, I have a prop, taking an arbitrary list of lines, and I'm going to assess, for example, that the maximum size of my resulting column should be the maximum size of the maximum row plus some space plus some characters for the delimiters. So that's my property. And then I run it, and what happens? Well, actually, the property breaks. And why is it breaking? If I look at this counter example, it's not necessarily readable here, but the reason why it's breaking is that if on one line, one string contains a new line, it's going to break all your formatting. So now you think, oh, yeah, of course, it's going to break my formatting. So that's a case I didn't think about it, that arbitrary strings can contain new lines, and that can break formatting. So ScalaCheck is helping you and to find this case, and then you can fix it by just removing new lines, for example, before you do your formatting. And the cool thing that you can do with Specs2, and I'm going to show you other examples in a minute, is that you can access all the ScalaCheck properties directly from the command line. So you don't have to recompile your code and pass other properties to ScalaCheck. You can just change them from the command line, change the maximum size of the generated data, for example, or change the minimum number of tests to say now instead of 100, I want to test all my properties with 1,000 times. This is actually quite useful, and I've had real bugs in production where the thing would occur only after 30,000 test cases. And ScalaCheck helped me find this. So don't hesitate on complex properties to crank up a little bit the number of minimum tests just to see if you're really sure it's a valid property. But more generally, in Specs2, you're going to use matchers to do your assertions. So out of the box, Specs2 comes with a lot of different matchers for strings, collections, features, options, and so on. And you are really encouraged to use them. But you are also really encouraged to create your own. I mean, your domain is probably unique, and you have your own language, and it's quite cool to create your own matchers for your own language. So for example here, let's say I have this function called Syracuse, and it's doing some computation. So anyone has an idea of what this thing is doing? Anyone knows about Syracuse as a conjecture? No? So it's very simple. So you take any number. If it's an even number, you divide it by 2. If it's not an even number, you multiply it by 3, and you add 1. And you repeat the process. And the very funny thing is that you always end up on 1. And up to this day, no one knows why. So that's one of the most famous conjectures in mathematics. No one has any clue of why we end up on 1. So it's very simple to state, but it's still a big mystery. So let's say we want to check some properties on this. That's my domain. That's the thing I want to investigate. And for example, the question I have in my mind is the sequence of numbers I'm going to get for n plus 2, is it going to be longer than the sequence I will get for n? Maybe that's something that could happen that could help me understand this conjecture. So in that case, you can write a specific matcher called have less steps than that says exactly this. That's exactly what you want to test. That's your hypothesis. And the matcher is implemented like this. You take the actual value of the list you get out of the function. You check the size, and then you compare both sizes, and then you can output a very clear message explaining exactly what's correct, what's not correct. And when you run this, with the help of ScalaCheck, you can find a counterexample. And because you have your own matcher and your own display of the error message, you can display some very nice things. And it's especially important because that you will be a lot more productive if you have good failure messages, because you would spend a lot less time understanding what goes wrong. So I really encourage you to bring on your own matchers to the table. So that's for, now we've described how you can specify tests using Specs2 by having informal text plus very precise code, maybe using ScalaCheck properties. So how all of this is executed. So one distinguishing feature from Specs2 is that everything is concurrent by default. So all the test cases are being executed concurrently. And this is to really encourage you and myself to have tests that are as much independent as they can from each other. They should not share any state, because that's really bad for testing. That really makes things harder to evolve and so on. So by default, Specs2 is concurrent. So if you have a specification like that, things will be executed concurrently. If you put some printlns inside the execution, you will see that the order in which things appear do not correspond to the order things are being reported. And this also makes your testing faster, because your test suite will execute a lot faster, because now it's concurrent. Unfortunately, you cannot do that all the time, because some of the testing has to be sequential. Some of the testing interacts with the outside world, for example. So in that case, if you want to say that something is sequential, well, you just say it. So there's an argument called sequential that you can put at the top of your specification like that, and it will execute everything in order. And not only you can do that, but you can also specify more. You can also specify things like, oh, by the way, before executing anything, I want to have some behavior like open a connection to the database and reuse that thing for all the examples. And eventually close everything, clean up all the data, I'm done. So with the trait like before and after all, and we will see how this is implemented, you can do this kind of, add this kind of behavior to your specification to control exactly what is executed at any point in time. OK, so that was for the execution. And now in terms of reporting, we actually have lots of possibilities using Specs2. So you've seen the console as your main way of interacting with your specification. But you can also have HTML reports. And to create the report, you just put the HTML argument on the command line, and that will output a report. And you can even go one step further and create a full user guide for your software, because it's possible to introduce inside your specification snippets of code that are going to capture some real Scala code and then report the code inside the generated HTML as code blocks. The real advantage of this is that your documentation will never stay out of sync with your code, because every time you refactor something, you will automatically refactor the code that's inside your class. And that's a really cool feature. Yeah, you will always have up-to-date documentation. And another way to get some information out of Specs2 is to use notifiers. So this is, for example, how it is integrated with IntelliJ. So a notifier is just a simple interface that is like a listener. So every time there's a failure, in that case, if we have a failure, we say, oh, please send an SMS. That's what's going to happen. And then you pass it on a command line, and that thing is going to be used as the main way to report the specification. So recently, I had some requests to integrate Specs2 with Bazel. And that was the easiest way to do it. Just use a notifier for Bazel, and that's it. So it's quite easy to integrate it with any kind of platform where you want results to happen. Another thing that's quite useful is, in terms of workflow, is how you can pick specific examples that you want to execute. Because sometimes you're just focusing on one small piece of code at a time, and you don't want to see the full specification, you just focus on one example. So in that case, you can just pass a subset of the name as a regular expression and say, I want this example in my specification, and this is the one that's going to be executed. But you can also go a bit further and by using the tilde thing in SBT that watches the modifications on your files, the tests are going to be executed every time you change a file, right? That's already nice. But you can also say, hey, please, can you rerun anything that was failing before? So you say, test my spec for anything that was with, you pass the status of the test. So bang is for errors, and cross is for failures. So anything that was previously an error or a failure, please rerun it. And it will just rerun those tests. You don't even have to name them. And eventually, you hope that everything will be green and nothing will be selected anymore. So that's something that should help you in terms of productivity, having a faster turnaround. And then there's another way to select things inside the specification is to add tags. And the tagging system in Specs2 is actually quite sophisticated, if you want. So because not only you can tag one example at a time, just adding the keyword tag, but you can also tag entire sections of your specification by using the keyword section. And then you can even have overlapping sections if you want to. So you can say now, can you please just execute the top part of my specification? And you say include just parse, and it will just execute the top part of your specification. This can be quite useful if you have a long specification and you want to re-execute it step by step. So you put a section tag at the beginning of it, and then another section tag. And once you're satisfied with the first example, you can just put the lower section tag a bit lower until you've reached the end of your specification. That's one way to incrementally execute stuff. Again, that's an idea you can exploit to have fun while testing. And finally, I want to talk a bit about the specification structure, because maybe there's a bit elephant in the room so far. All the specifications we have seen were using a specific format, where you see all the text for the informal text, and then some small markers, and then all the code to implement all the tests, if you want. So there's a real separation between the text and the code. And if you come from other libraries like JUnit or RSpec or whatever, you are used to a style where you have blocks, and in each block, blocks are nested, and you have more like a bit of description, a bit of implementation, a bit of description, a bit of implementation. So you can also do that with Specs2. And as we will see later on, this is called the mutable style of doing specifications, because it's doing something evil, and we will see exactly what. But this is also possible. And finally, so that's the presentation. And finally, there's a curiosity that I don't think many people are being aware of, is in Specs2 you can have specifications which write other specifications. You can create specifications at runtime if you want. So this can happen if you are doing things. So recently I've used that for end-to-end tests. So you start some tests across different systems. You don't really know what's going to happen once you reach another system. And there's no use in testing any more things if something breaks. So you can have a specification where you say, hey, can you find if someone is on call for maintenance? And you want to make sure that at any point in time, you always have someone on call with a name, and that person has an accessible phone number. But you have two cases. Either the person on call is a developer, and that guy or girl has to work, has to have a phone number, or that person is a manager. And manager, what do? They just delegate to another developer. So then you have to check something else that's slightly different. You have to check that the manager has delegated the maintenance to a developer. So this is a specification where the shape of the specification itself is going to change depending on what you find in the database, for example. So you can write something like that, and then you have, when you execute it, you have three different possibilities. So either you don't find anyone on call, that's a failure, or you find someone who's a developer, or actually the first one is a manager, and you can check that there's indeed a developer that will actually do the maintenance, or you have someone that does a developer directly. So as you can see, the output will be three different specifications, and it's only going to be determined at runtime. So maybe my question for you is, can you think of a feature from functional programming that will enable this kind of behavior? So that's a small quiz, and we will see at the end what it is. Maybe try to think about that. What kind of feature in functional programming can support this kind of behavior? We'll have a look. So if you had to build such a library, where would you start? What kind of data structure you could think of? How would you structure things? What kind of components, modules? Where would you start with this? What I want to show you today is that the main concepts, the main ideas are actually quite simple because we just rely on a few concepts. So a specification basically is just a list of specification fragments. And the fragment is two things, an informal description, so it's a description, and something you can execute. That is some code that's going to return some value. And that's all it is. So a specification is just a list of things. And you can have different types of descriptions. And an execution is anything that's going to return a result. And we're going to see that by just playing on different types of descriptions, different types of results, different types of executions, we can implement lots and lots of behavior. Actually, I need to say right away that result is more like there's a type class for results. So actually, a result in Specs2 is anything that can be converted to either a success or a failure, or maybe a skipped result. That's it. So we'll see some examples of that. So how do you assemble all these ingredients now to form something that you can execute? Basically, it's just a bunch of functions. So you have a select functions. What does it do? It takes the list of fragments that you created when you create your specification class. It selects, based on the arguments you pass, which ones are interesting to you, because you might not want to execute everything, and just returns the rest. It's just a filter. The execution is a bit more elaborate, but does almost the same thing, takes each fragment one by one, and just start them concurrently, and that's it. And the printing, same thing. You take your list of fragments, and you just print them out to the console. So in first approximation, that's all Specs2 does. Build the list of fragments, filter it, execute it, print it. It's just one line. But we're going to see now, revisit all the examples I gave you, and I'm going to give you more information about exactly how this is done using this. So in this case, we need to create those fragments, right, from an interpolated string. So how does that work? So the string interpolation gives you back all the different pieces. So if you look at the API in Scala for string interpolation, it gives you some pieces. So once we have those pieces, we can say, oh, the first part is just some text, and we stop at the new line. The next part is probably an example, something that has both an informal description and something that you can execute. So this is going to be called an example. And this is going to be the execution inside the example. The next part is just a piece of text, and then you have another example, and you finish with a piece of text. So basically, everything that the string interpolation gives you is translated to a Specs2 fragment, having a description and/or an execution, and that's it. For the API, it's actually a bit more tricky, because unfortunately, when you have the string interpolation in Scala, just returns the values that are interpolated, but not the text corresponding to those values. It does not capture this text. So in order for me to capture the text, to render it on the console, I had to implement this as a macro, and use some macro stuff, and use an option called -y range pos, which is a compiler option that's going to give you more or less information on where a value is inside your source file. This is a bit tricky. This generally works well, but also discovered that this can crash the compiler in some cases. So if that happens to you, you're not completely out of luck. You can just remove the option. And are you kidding? I'm counting 24 minutes. Okay, I have more time, right? It's OK. So yeah, you can remove this option, and then there's a heuristic that will just try to approximate what needs to be extracted and displayed. Tables, well, there's not much magic here because we're just reusing Scala operators. Like pipe is a Scala operator, bang is a Scala operator. They were specifically chosen because they were more or less looking like straight lines compared to other operators, like it was nicer for tables. And also they have a low precedence order, so meaning that you shouldn't have to put parentheses inside the cells to avoid ambiguity. So that works quite OK. ScalaCheck properties. This one is a bit tricky because if you use ScalaCheck every day, in your properties, generally, you are restricted to just return Booleans. And Booleans are not very expressive. And in Specs2, we have lots of matchers, so we want to use them. That's really cool to be able to use matchers. They are a lot more expressive. So we have to do some gymnastics here. So we have to go from a function returning a Specs2 result to a prop, something that ScalaCheck understands, that we can pass to ScalaCheck. And now, once we have executed this property, we need to be able to pass back the results to Specs2 to build a proper Specs2 result. So there are like two conversions back and forth between Specs2 and ScalaCheck to compute the results. And it's actually a bit more complicated because in Specs2 you have the ability to specify at the level of each example exactly how you want ScalaCheck to execute things. So in general, with ScalaCheck, you can just say, execute the minimum number of tests, OK, should be 100 or 1,000. But this is going to be for everything. But not everything is equal. In some specifications, you want to say sometimes, I would just want this example to be executed 1,000 times. Not everything. I don't need everything to be executed 1,000 times. So in Specs2, you can just annotate your example and say, now, please, just for this one, 1,000 times. And you can do a lot more. You can specify that you want to see the frequency of your data. You can specify things like how things will be displayed on screen, like changing the toString methods for some of the things. You want to say, just for this example, I want some different generated data. So we can pass, for the third argument, you can say, oh, I want the generator to be exactly this, because this is what makes sense. So there are lots of goodies with this integration. So I really encourage you, if you like ScalaCheck, to have a look at the integration with Specs2. Matchers. So matchers is not very complicated. It's a matcher is something that can match some expected value and actual value. And it's a real matcher. The matcher class is a bit more involved than just a function returning a Boolean and a message. But there's a conversion from this to a real matcher. And just having this works well. And once you have a matcher, you can connect it to the actual value by using must. So you can say ABC must contain A. And this will create a match result. So a match result is essentially a result, except that only it just contains more information. So not only you can see if it's a success or a failure, but you can also see what was the actual value, what was the expected value. And this allows you to have some more complete reporting at the end of your specification. Concurrency. Yeah, so I lied a bit to make things simpler. So an execution in Specs2 is not only a function that returns a result, but it's a function that returns the future of the result, because we want things to be executed concurrently. And it also takes an environment, because you need to be able to specify the execution context you're using for that future. So it's a bit more involved, and it also has the value that is currently executing once you start your specification, because you want everything to be executed concurrently, and you want the results to hit the console as soon as they are available. So this is basically how this is implemented. And to implement sequential, as we've seen, it's like just a keyword. And at the beginning, I said, oh, a specification is a list of fragments. But this keyword is not really a fragment. It's not something that can be executed, that has a description. So a real specification is more like a list of fragments and a bunch of arguments that you are going to use to drive the execution of your specification. And arguments can come from many different places. So they can come from inside the specification, like this. They can come from the command line, or they can even come from Java properties. So for example, in IntelliJ, that's more or less the only way or easiest way to pass those arguments in IntelliJ. And then they are merged together to be used during the execution. Steps. So the other thing we saw in the database example was how you could have some behavior like at the beginning of your specification and completely at the end. And how is it done? So it's done more or less like the rest. So a step in Specs2 language is just a fragment, but it's a fragment that has no description because it's not really a test, not something that you need to specify. It's just an action, like do something now. And it will only be reported if there's an error. I mean, if there's really a problem with you trying to open up the database, then you will see an error being, oh, step X failed, you need to fix it. And steps, they also play a role in the sense that this specification here is completely sequential. But you could have a specification where you want some parts to be concurrent and some parts to be also concurrent, but some synchronization in the middle. So you can put a step inside a bunch of separating two groups of examples, and they will all synchronize on that step, check the results, and maybe do only the rest of the specification if everything is okay. So it's also a way to control the level of concurrency you really want in your specification. Notifiers and reporting. So reporting is actually quite cool. I really like it because it's kind of a challenge. In terms of reporting, what you want is to have different reporters that are going to output some results, but you don't want to run your specification several times. You want to run it just once and have all the reporting being done at the same time. So how can you do this in a way that's very composable, where you can say, oh, now I want both the console reporting and the HTML reporting and maybe my notifier to my other system at the same time in just one pass. And also without having to compute everything into memory as a huge list of results and then parse this list of results to do the outputting. Because then you would have to wait, nothing happens, and then boom, all the results. That's not so nice. So the answer to this is quite involved, and it involves talking about side effects. It involves talking about streaming and talking about folds. So this is actually the subject of a completely other presentation, which I did. Lots of those ideas were presented at Scala World previously. So I really encourage you to have a look at the video when it's out. But the idea is that there's a small streaming library inside Specs2. So it's not really a list. It's more like a stream of fragments because we don't want to have everything in memory at once. We have a small implementation of some effects to deal with I/O and futures and concurrency and all of that. And then there's this idea of the fold. So I'm just going to say one word about this today because that's just an idea that I love. So all the reporters in Specs2 are actually folds. So they are objects that are going to receive all the elements of the stream as they arrive and do something with those elements, like outputting them to the console or filling in an HTML file. And the cool thing about folds is they are super composable. So if you have two independent folds, you can just compose them to create a big fold. So when you say on the command line, execute my spec with a console reporting HTML notifier, internally we build those folds. We just compose them in one fold that's going to do all the reporting all at once on your specification. So on a very simple example like this, you would have like emitting elements like 1, 2, 3, and you want both to count the number of elements and find out which one is the maximum. You can implement this as two folds, one for counting, one for getting the max. You zip them together, and then you can have in one pass all the information you need. So that's basic stream processing. And maybe you heard about folds, streams, and things like, and you're wondering, what am I using? It seems like lots of functional programming. Is Specs2 using ScalaZ? Is it using cats? What? And actually, Specs2 was using ScalaZ for a long time, and I've been using ScalaZ Stream specifically. And this has been a huge maintenance burden, because if other people were using ScalaZ, they had to, I had to publish a special version of Specs2 for their specific version of ScalaZ. So for years and years, this has been a problem. This is not the case anymore. So Specs2 now is free from any dependency of any functional library. But this all means that I had to re-implement my own. That internally I had to re-implement monads, applicative, functor, all the things you might find in those libraries that are very useful. They are not in the standard library. And actually, it turns out that it's a fun exercise, and it's not so hard. I mean, I don't need the full extent of those libraries. For the subset I'm using, it's not too hard to implement. And now my quiz. So what kind of functional programming functionality you think is being used to have specs which can write other specs, like discovered at runtime? Anyone has a guess? Some enlightenment? Yeah, monad, exactly, in one operation, flatmap. So we have a stream of fragments. So this stream is actually also a monad. So you can have a flatmap operation on it. And the flatmap takes each fragment and maybe produces other fragments. That's just the thing that we're using here. I think that's a very cool lesson. That means that if we can sometime discover the underlying structure of what we're doing, like, hey, maybe that thing is a stream. And then you can think, oh, maybe because that's a stream, I have some operations like flatmap. What does that mean to have flatmap on the specification? Is that something useful? Actually, it might be something useful for testing. And actually, in the literature, this is called online testing. I mean, tests that are being discovered at runtime, this even has a name in terms of testing. This is online testing. So monads can be used for this, and that's for free. OK, I'm going to go quick on this. So selection is not a difficult feature. It's just about putting some markers inside the specification that have no execution, but a pure description, just used for the filtering algorithm to know if something should be kept or not. That's nothing fancy. This one is a bit trickier. So this thing has to be a mutable specification, because this is some code that's inside the body of a class. So this thing is going to be executed as soon as you instantiate your class. That's how it works. There's no other way around this. So this piece of code, if you want it to be registered somewhere, to be able to execute it, to report it, the only way you have is to attach it to a mutable variable. So there is one mutable variable hidden here that makes the whole thing mutable. And actually, you have to repeat the process for every block you open. Same thing. A block is actually a list of statements, which means that if you were purely functional, only the last one will be important. The other ones will be completely discarded, not useful. But we want the other ones. So we need to have some mutation. So in order to enable this nice notation that some people like, having this nesting and all, we need some mutability. So mutability is used on Specs2 on top of the immutable style as some kind of DSL. But I try to restrict it. It looks innocuous and not so difficult. It's actually, yeah, that's just to, maybe I should say a word about that. That's important. The style you can see here is actually showing some nesting, right? And I told you from the beginning that a spec is more like a list of fragments. But here we have a tree. So how do we do with something that has the structure of a tree, which we might report in JUnit as a tree, with a list? So the trick is actually just to insert some fragments that are going to be used as markers. So you can transform a tree into a list just by putting some markers saying, oh, now I'm opening a new sub-level of my tree. And then now I'm closing it. So everything in between was just children. So this is basically how we can go from a list to a tree, and we can reconstitute when we parse the stream at which level we are, depending on these markers. And that's again, a nice analogy. If you notice that a list can be made isomorphic to a tree, this opens up lots of possibilities. This is what we do here. But this thing with mutability made my life really horrible with one feature. This is the isolated feature, something I didn't talk about before. So you can have this small keyword called isolated that's going to isolate each example or each group from the other one. So if you do some mutation because you're testing, I don't know, Java properties with one example, you want the other example to be isolated, not have to do a reset or a cleanup or whatever, just to be completely isolated, which means to actually execute in a complete copy of the same class. This is what the isolated keyword does. But the implementation is just horrible because it's side effecting everywhere and with mutation everywhere. And you need to instantiate a new class for each example, keeping track of exactly where in the path, in the tree you were. Make sure you don't evaluate anything else. So yeah, mutation again can be super convenient, but also it can bring implementation nightmares. So there are a lot more features in Specs2 that I would have liked to talk about today. Lots of small things that can make your life easier. I really encourage you to have a look at the user guide, browse through all those links. Maybe 80% of them would be completely useless to you. 20% will have a haha moment where you say, oh, that thing is cool. That can really help me in my testing, in my specification. So there's a how-to page. There's a detailed topics page where you can learn more. And main idea is to have fun, is to make the act of writing specifications and refactoring them and evolving them really fun and interesting. And I think that's all I had to say for today. And I'm on time. Okay, so do you have any questions? Yes?
Is the new S2 string interpolation thing some new feature it's added because in Specs2, sorry. I was using Specs2 2 years ago.
Yep.
And I don't remember such a thing. We were writing it like you have a sentence, and you say, okay, my class should be doing this, and you open a block and inside the test every function like usually.
Yep. Yeah, so I need to repeat the question. So is the S2 string interpolation new? And because this gentleman here was previously using the mutable style, opening blocks, and so on. So actually, once there were interpolated strings in Scala, I jumped on it. Because there used to be another, an immutable style before, from the beginning. It was quite horrible, because I had to link all the text fragments with some caret operators and doing some, it was not so nice to write immutably. And once I saw the possibility of having interpolated strings, yeah, so I think it was at least 3 or 4 years ago now. So it's been there for some time. Yeah, I just regret that the interpolated string don't give you the part for the interpolated variables. I'm missing this, so maybe I can do a SIP for this. I should do it. Anyone else? Yes?
What's the main report? So basically, if you write the specification in the Scala code, the goal is to output it in the console mainly, or can we do some customization for HTML report and move to the console, or maybe in IntelliJ also? So can we have, for instance, kind of format inside the code, and depending on the output, we can have simpler or more complex presentation? Because I would like to have three, for instance, three outputs. One, the console when I run the CI.
Yep.
And the CI, you can also run the HTML report.
Yep.
For the business part. And for instance, when I run my test, when I develop, just the GUnit or specs to plug in.
So the question, if I understood, is what's the main report, and maybe how can I customize some of them and adjust them depending on, is that right?
The way to write it, and I have the full, for instance, I want to have the title, the H1, H2 in the HTML report.
Yeah.
But I don't really need it in the console. Do we have some kind of way to do it inside the code?
Okay. So so the way it's being done at the moment is that in the first mode is just the console mode. So by default, you specify no argument, it goes to the console. And you can enable the HTML mode. And as you have seen on the examples, you might have noticed some markdown notation, right? So by default, if you run the HTML mode, Specs2 will try to interpret all the text as markdown and do the corresponding reporting like this. So the things you can change more or less easily is the CSS. So you should be able to push your own CSS file that's going to override the one that Specs2 is using. Otherwise, all the rest is pretty much fixed. The idea of the console mode was that, especially for the immutable style, was that everything you put inside your specification should be outputted more or less the same. But maybe what you're saying is that you would like to strip out the markdown notation, which is useless for console mode. Yeah, so I think it's possible. I think it's possible. I never had that need myself, so I didn't do it. I don't see why you could not write your own reporter that would do the exact same thing based on the existing one. It might be a bit tricky because then you need to do some parsing on the corresponding fragments, and your parsing needs to understand what is the markdown notation, and so like I mean it can be tricky because if in your code you have like a hash, but that's in the block of markdown that should be rendered as code, it's not the same as a hash that's used to mark a title, right? So stripping out all the markdown notation from the actual text might not be so easy. But it could be a fun hack project. Okay, come to see me afterwards. Any other questions? Don't be shy. No? Okay, anyway, I'm available live or online, whatever you want. Thank you very much.